Today we'll get started with the continuous monitoring tool, which is Prometheus. So let's talk about what is monitoring and why do we need a monitoring tool. Monitoring is like we are having our infrastructure, right? This infrastructure or the service, not only infrastructure, any services, any application status, application health, all of this has to be monitored, right? So we need a monitoring tool which can help us monitor 24/7. If it is a small infrastructure, we can log into the servers, we can check the health of the application, we can do all of this manually. But imagine you have infrastructure, a huge infrastructure. Logging into those servers manually, checking the health of the services, applications wouldn't be possible, right? So we need a monitoring tool, particularly in the DevOps methodology where we are automating 24/7. Monitoring and alerting are crucial so that we know what's happening on which server. Right? Monitoring is not only that it identifies something which is wrong, it will also inform us beforehand, a kind of warning. Right? Like for example, if you take a disk space, it will inform you when the disk space is 70% itself, not just when it is 100%, so that you can take necessary steps and see that the system is not failing or the server is not failing because of the full disk space, right? So all of these things can be possible with a monitoring tool. Like it can help us warn before the actual problem comes in, and it can help us monitor the huge infrastructure. It can help us receive timely notifications so that we'll see the actual servers are not impacted, actual business is not impacted. It's very important and crucial. This is called monitoring or observability, and we have so many tools under this category. Today we are going to cover Prometheus. Each tool has got its own pros and cons, or it has its own strengths and weakness. So we are talking about Prometheus, which is great for monitoring container-centric environments. Not only container-centric environments, any servers, any services can also be monitored, right? But it's more like majorly for container-centric environment. That's the need for that's the DevOps approach nowadays. So Prometheus can help us monitor the infrastructure end to end, and it can help infrastructure of any size. So, how Prometheus work and all, let us see. You have different tools, right? Like there were so many tools for log analysis. There were separate tools like Splunk for application monitoring. You have app dynamics. You have many monitoring tools, hundreds of monitoring tools. So there might be multiple monitoring tools used in your workplace, or else depending on the requirement, tools would be chosen. So here we are going to learn Prometheus. And Prometheus works on pull configuration, meaning it will pull the metrics from the targets. Suppose Prometheus has to monitor certain infrastructure, let's say 10 servers. These are called targets. Mm. Okay, suppose it has to monitor 10 servers. These are called targets. Prometheus will pull metrics from these targets, right? So it's called pull-based mechanism, and which is very effective and efficient, unlike push-based mechanisms. Like Nagios works with push-based mechanism. So let's see the architecture of Prometheus first to understand this in detail. Let me give you a small brief on how it pulls. Like this is the target, right? Suppose there's a target server, it has to monitor it. It will pull the metrics from this target. But how does it pull the metrics? It will pull the metrics from the target from a URL or a port number. What is a URL or a port number? How do you get that? First of all, this target should expose the metrics to URL or some port number. So once a target exposes the metrics, then Prometheus will pull the metrics from that URL or target, right? And also target expose the metrics to the URL in a language which Prometheus understand in the form of key value based text-based metrics. So once it pushes the metrics, your Prometheus will pull them. That's called scraping the metrics. Scraping the metrics at regular intervals. Scraping the metrics means pulling the metrics at regular intervals. You can configure the scrape interval like 5 minutes. Every 5 minutes it will scrape the metrics, right? So how does a target expose the metrics? All of that we will see. Let's get into the architecture of Prometheus. So this is the architecture of Prometheus. Prometheus server where Prometheus installed is called Prometheus server. That's a Linux machine. Any version, I mean, any distribution of Linux is fine, but that should be Linux. So that's a Prometheus, and like you see, it will pull the metrics through something called data retrieval worker. There is a component called data retrieval worker which will pull the metrics from the targets, and those metrics will be stored in a database called time series database. It's called TSDB, time series database. Data will be stored in the form of key valued pairs, right? And so data, once it is stored, that data can be shown on the Prometheus GUI. Yes, Prometheus has got a graphical user interface as well, but a basic one. So those metrics will be shown here. How is this GUI deployed? That is deployed on a HTTP web server, right? So on the web server, Prometheus metrics can be seen on the GUI through the Prometheus web GUI. That's one way. And there is also, like, suppose if there are any metrics and all, there is something called alert manager, which will send the alerts. This is another component which need to be installed separately. And also to find the metrics, we'll have the PromQL, Prometheus query language, by using which we'll query the Prometheus server and scrape the metrics. So this is how you have the Prometheus server with the different components: data retrieval worker, time series database, and HTTPD web server, different components that works. So this is a simple architecture. It pulls the metrics, stored in the DB, and HTTP web server will query this server using Prometheus query language, means simple queries, through which it fetches the data, and also the data can be seen on the GUI. That's all. And there will be certain jobs where pull configuration cannot be applied. Certain tasks, certain jobs, short-lived jobs, batch jobs, right? For those, you may not be able to use pull. For such jobs, push configuration can be applied. That's where this push gateway component will be helpful. There is something called push gateway, which can help you get the data from the short-lived jobs through push metrics, push configuration. Any questions in the architecture? This is the architecture of Prometheus. If you are clear, we can go for the setup of Prometheus server and start monitoring the targets. Any questions from anyone here?
I mean, the labels, what is time series database, ma'am?
Data is stored in the form of a time series,
Okay, all right.
like as per the timestamp, and it is stored in the form of key valued pairs.
Okay. And what is accepts PromQL queries?
Prometheus query language.
Prometheus query language. Okay, okay, all right, ma'am.
Query to fetch the data, like you want to see some uptime and all, you will see the query.
Okay, all right, ma'am.
So let's go ahead and configure Prometheus. I'm installing a server. I'm creating an EC2 instance for installing Prometheus server. T2 micro, key pair is demo, launch the instance. This is the one. Let's connect. So let us install Prometheus. You can install Prometheus in multiple ways. Right. So you can also install it as a container. I'm planning to install it as a container. Like you remember, right? There are so many Docker official images available. We can use some image to install Prometheus. Also, along with Prometheus, I would like to install Grafana, also the visualization tool. Prometheus is a monitoring tool. Grafana is a visualization tool. So I would like to even install it. So first to install Docker, let us install Docker first to run it as a Docker container. Docker. Okay, also I would like to deploy in Prometheus, Grafana, and for example, I want to monitor some Redis DB, I'm going to install it. So multiple containers. How do you install multiple containers? How can we manage multiple containers? Docker Compose. So I'm installing Docker Compose as well. You could install just in the normal way also. I want to install the stack. So Docker Compose should be installed now. Perfect. So now obviously to do this, we need a compose file, right? We'll create that. Here I'm going to create a directory called Prometheus stack. Now write the compose file. Let's say docker compose.yml. Put the compose file here. So this is the file. Like if you see, I'm launching Prometheus container, Grafana, Redis, CA Advisor. What is CA Advisor? CA Advisor is another service which can pull the metrics from other targets, from other containers. Let me tell you one thing. So actually this is my Prometheus image coming from this one. Container name Prometheus runs on 1990. I'm forwarding it to the same port on the host. Prometheus needs a file called prometheus.yml to get started. I'm passing that from the volumes. And so this is the volume. Okay, I'll create this file on my host that will be copied. That is depends on CA Advisor. Means first I want CA Advisor to get started. It's coming from an official GCR Google Container Registry and it runs on 88. Ignore all of that. So CA Advisor is a service which can pull metrics from other targets. See, Prometheus has to monitor Redis, but Redis is not defaultly exposing its metrics. So we need something which can pull the metrics. So CA Advisor is the one which will pull the metrics from other containers and shows that on the UI. So means an endpoint. So I'm using CA Advisor for that purpose. Redis, which is being monitored. Even Grafana, I want to use it as an visualization tool. It runs on port 3000. So 4 containers will be started: Prometheus, CA Advisor, Redis, Grafana. And Prometheus is dependent on CA Advisor, CA Advisor dependent on Redis. So which one will be started first? We have learned these things in Docker Compose. So as per this YAML file, which one will be started first? So, yeah, these are the 4 containers which will be started, and first Redis will be started because Prometheus is dependent on CA advisor, CA advisor is dependent on Redis. So Redis will be the first one to get started. And also we need a Prometheus.yml for Prometheus to start, right? I'm creating it here itself so that that will be copied into Prometheus container via the volume we configured. So what does this have? This will have the scrape configs and the targets. So here the target is CA advisor because Prometheus is just monitoring CA advisor. CA advisor in turn bringing the metrics from Redis. So that's how it will be monitored. So this is what I have. Job name means the target name, scrape interval, static configs. Let me save this and run the compose file. Sorry. Docker compose up to -d. So you can see here containers are getting created. See here, all the containers were ready. Let's see. Docker images, it should have all the 4 images and all the 4 containers forwarded to C Prometheus one on 1990, C Advisor on 8080, Grafana on 3000. We need all of them. Let's add them in the security groups. Edit the inbound rules. 8080 to see the C Advisor. 1990 for Prometheus and 3000 for to access Grafana. Okay, now let's get the public IP. Hit that on 1990. We should see Prometheus. Right, you might have remembered we deployed it in Kubernetes cluster also in the earlier classes, but we haven't learned there. We have seen this. This is called metric browser or metric explorer. If you see here, you will see explore the metrics. These are all the different metrics. Like I want to see some data of Redis. You can see here. See Redis. Scrape duration seconds. It's not showing with Redis. Let me check with the node data. See, this is all the node data. Redis comes as a container. Those information you can see. And that's the query where you write. Actual simple queries up means will show you how many targets. You have one target. It's up one means it's active. It could scrape. You can see that in tabular format or the graph format. Also, if you want to see 1 hour data or 2 hours data, or else I'll see with 5 minutes data or 1 minute data, you have all of that, right? This is the line which indicates in the graphical format, in the tabular format, right? And out of all this, there is something called status. Here, if you go configuration, you can see all the configurations we have and the default configurations also you can see. Also, we should be seeing the target. One target, right? And these are all the labels added by default. Like we created job name CA advisor. That's how it got it. And this is the endpoint where CA advisor is posting the metrics. Get the IP address 8080/metrics. Okay, see, this is how you can see CA advisor is sending the metrics or pulling the metrics. If you see here, you can see Docker containers, all of that. If you go to Docker containers, Redis is what we are observing. You can come here, isolation, CPU, memory usage, you can see all of this. Understood? So this is the CA advisor and the containers, right? Is this clear? So it's exposing the metrics to this endpoint, right? The slash metrics is the endpoint. CA advisor is pulling the metrics. It's exposing the metrics here. From this path, Prometheus is scraping them. Is this clear? Understood the flow? CA Advisor is a service which will pull or which can have contain metrics from other containers. That's why we deployed CA Advisor, because Redis cannot expose its metrics directly like this. So once it gets CA Advisor is pulling them, we added CA Advisor as a target, which will have metrics of all of those. Clear, everyone? See, Redis data is here. All of that it can monitor. Hope the flow is clear for everyone. Now let's launch Grafana for visualization. On port 3000. Admin and admin are the password. Skip. So this is a visualization tool. Means see, Prometheus has got limited visualization, right? Just table format, and if you just go here, table and graph. But in Prometheus, if you go to dashboards, you have to see it's just visualization tool. Grafana is not monitoring it. It's a visualizing the data. So how does it visualize the data? I mean, how does it visualize? You have to connect it with a data source. How do you connect it with a data source? Here you can search Prometheus data source. Sorry, I came to dashboards once again. First, you need to connect to the data source. Go to connections, add a new connection. See, there were so many plugins. Means Grafana is one which is not just connecting, which can not just connect to Prometheus. It can connect with, these are all the different data sources it can connect with. Google Analytics, Adobe Analytics, or Redshift, IoTDB, whatever, Atlassian status page, AWS Sitewise, Azure DevOps, Business News, CloudWatch alarms, different services it can connect with, right? It can connect with other tools like GitLab, GitHub as well. Jaguar it can connect with, Kafka it can connect with. So MySQL Server it can connect with, Neo4j it can connect, New Relic, and so on. It can connect with various data sources, databases, to visualize the data in a better way. See, to Redis server, if it is separate server, even it can connect with it, right? Or RabbitMQ, Splunk, it can connect with the Splunk to visualize the data. Here is Splunk as well. Okay. So we are connecting with Prometheus. So search for that data source with what you want to connect. This is the one. And then add the new data source. Here you should provide the URL of this data source. I would prefer the private IP address so that even after restart it should be working. 9090. It should start with HTTP. Okay, now test it. Test the connection. Save and test. See, successfully able to connect. Perfect. So it is added, that's all. Now, when creating dashboards, Grafana is a visualization tool through which you can visualize the data in a better way. So here you can create a dashboard. New dashboard, add visualization, see, select the data source. Here you can, whatever queries you are having, this is nothing but a prompt query, a simple up query. So those all metrics you can see, means whatever you can see here in the Explorer, right? All of that you can see. Let's say I want to monitor containers, FSI nodes total. So the same, you can visualize it here, but this has got basic GUI. But if you want to present in a better way, you need this GUI, graphical format, tabular format. Graphical format, I want only 30 minutes data. Similarly, choose the metric here. Once you select the metric, run the query, you should be seeing the data. See, it is showing 6 hours data. You can change it, 1 hour or 30 minutes data, and you can save the panel. Let's say metric 1 or panel 1. And also you can visualize it in different format, time series format, default format. See, these are all the different visualizations you can have it in Grafana. See, bar chart or a stat format, gauge format, bar gauge, table, pie chart. It's up to you. It depends on what you want to monitor, how you want to present it and visualize it. Save the dashboard with that panel, right? Save the dashboard. See, we have the dashboard with one panel. Likewise, you may create multiple panels because it hundreds of metrics a monitoring tool will monitor, but it will not visualize all of them, right? So this is how we can work on different panels. Any questions? If you remember, we have deployed Prometheus in a Kubernetes cluster, right? If you want to monitor cluster, you have to deploy the same way. So once you deploy with the Helm chart, like if it is coming up with the metrics which it has to pull, and so once it is installed via Helm chart, you can monitor all the Kubernetes metrics. So the same thing, almost similar thing here. So as of now, we are having only one target. You could add multiple targets to it. Any questions? Okay. Hmm. Already it's monitoring this this CA advisor, right? Let's say I want to monitor another Linux server. How can Prometheus monitor another Linux server? Let me create it. Let's say target one or server one monitoring. K-pair, select it. You want to monitor another Linux server, but how can you monitor the Linux server, another Linux server? It should expose the metrics, right? Is it exposing the metrics? If not, how do we monitor it? Let's see. Um, okay. So this is the one we want to monitor. Let me connect to this. Okay, so if you have to monitor, if Prometheus has to monitor this Linux server, how does this Linux server expose? It should expose the metrics, right? Does the Linux server by default expose the metrics? Not all of them will do, right? So how is this possible? How can it expose the metrics? So there are something called exporters in Prometheus. Exporter is like a program or a plugin or executable which runs on the targets to expose the metrics, because they don't default expose the metrics. There were so many exporters, like if you want to monitor anything, always refer this official documentation. Right, so here you can see something called exporters. Right, there are a number of libraries. You can call that exporter as a program or a library written in some programming language, which will help in exposing existing metrics from third-party systems through Prometheus metrics. This is useful for cases where it's not feasible to instrument a given Prometheus metrics directly. So that's where these comes in. See, these are all the different exporters. Messaging system exporters, storage exporters, HTTP, APIs, they were categorized, right? So these are all different exporters you can use. These are all related to database exporters, like MongoDB exporters, PostgreSQL exporter, and so on. Hardware exporter. See, because Prometheus can even monitor the hardware, like disk usage exporters, IoT edition exporters, issue trackers, Jira if you want to monitor Jira exporter, and so now I want to monitor Linux. So you have to use something called node exporter. This one, node or system metric explorer. Right, this is the one we are going to use. So it's just like you have to install it here on the target and configure it. So let us see how to install it. It's less like any the software, any package. You can install the executable, provide the permissions to the executable, and also let us install it. Okay, I'm downloading the executable. I'm downloading this node exporter as a tar file. Extract the tar file using tar command, and it might have extracted. Go to that folder, and I'm copying that to USR local bin. Okay, so once it is into local bin, I would like to start it as a service, right? I would like to start it as service, so I would like to create a service file. This is a Linux concept. I'm creating a service file by name node exporter.service, and I would like to write the configurations, the location of this executable, how I want to start it, and all. So like I told, this is a Linux concept. So adding the unit service and install unit where you will put the executable name and how do you want to start. Once this file is started, start the daemon. Systemctl daemon reload. Sorry, reload. Okay. Now you can start node exporter. Systemctl start as a service. If you want to check the status. Okay, you can see the status. It's on the process ID 2510. It's active and running. You can see that here. LNTUP pipe grep 2510. Let's start. Okay, see it is running on 9100. Node exporter also runs on 9100. You can visualize this here as well. Let's go and get the IP address. This is the server's public IP. Go to security. Inbound rule is 9,100. Do you see node exporter is running, and this is the URL or the endpoint it's exposing. After installing node exporter, it was exposing the metrics to this endpoint or a URL. If you go here, right, you can see all the details of this particular node. Like, see, node disk space, node disk usage could be the metric. Right, so these are all the details. Node disk disk bytes total. I can grab that and I can check it here as it is exposing. Oh, it is exposing the metrics, but we did not add it as a target, right? See here, it's not as a target. What should we do to add it as a target? Only C advisor. We need to add this node exporter. So what should we do? Where do we add the target? Now go to Prometheus server, where Prometheus is running. Here, if you go to this folder, we have prometheus.yml, right, where we add the targets. This is where we should add another target like C advisor we have added. We should add this new target, which is like you could put some name, job name could be C2 instance or whatever. Okay, job name is EC2 Linux static configs. Here you should put the IP address of the server. So let me get the IP address again. Public IP or private IP you may put. Right? So second target, this is job name, C advisor, job name EC2 Linux, static configs and the URL and the endpoint where it is exposing the metrics. So save it. Now this new file should be copied into Prometheus container, right? So already containers are running. So terminate this. I'm forced removing Prometheus container will restart it with a new file copied into the volume. Container name is Prometheus. Okay, now you don't have that container. Now let us run the compose again. Docker compose up -t. See, container started. Let's see PS. Yes, it's up and running. You can also go inside and check where it is copied. As per the configuration file, as for the Docker compose file, this is what we want to place etc Prometheus. So check that. Inside the container, it should be copied. Docker exec -it. Container name is Prometheus bin bash. Actually, it is sh is the executable here. It's not getting. Exec -it. Container name. Okay, just sh will do. So you got into the container. So you have got logged in. Now we should check in the path. HC Prometheus. So here is the file which is copied through volume and it has got the new target. Understood, everyone? So just coming out of it. You should see your container running. Now let's come here. We should see the new target. Go to the status, target health. Perfect. Do you see that? New target. Also, when you run up a simple command, simple metric, there should be two targets. One means it's up, two targets. Now, if you want to monitor any metric, like whichever you are seeing here, read bytes total. Right, you can check here in the graphical format if you want, you can check. Right? Is this clear, everyone? The flow. Any questions from anyone? Is this much clear for all of you? Node file system available bytes. Right, you can check here in the tabular format as well as graphical format. You have got multiple values. So now the same if you want to visualize in Grafana. Yes, add the visualization. Add that metric. So here it is, run the query. Why it was showing no data? Okay, it's because we choose okay, now it has got the data, that's all. So let's say some metric name or a panel to I'm giving. Save the panel. Save the dashboard. Back to dashboard. See, you can see two panels. If you want, you may align it in a different way. Like let's say you can drag and drop those widgets however you want it to be. Right? You can also choose the themes, like it's a black theme. You can also choose that is under preferences, I believe. Settings, variables, links, versions. There is something like theme what you want to be. I'll show you in some time. So these are all the different things. If you want to edit that later, go and edit. I want to see it in a different format, like bar chart. This is also fine. So that whichever metrics you want to monitor, you can put them here so that this dashboard helps users, developers, everyone to know about the issue. Not only that, we can also configure the alerts, but for that you need to configure alert manager separately. And also you need to have some SMTP server to trigger the emails. You should have your own SMTP server. Save the dashboard. Here are all the default preferences. See here, preferences. It's a default preference. You want to have a light theme, you can save it. You can have this white theme. Right? It's all about visualization. How effective you want to keep your visualization, have your visualization. That's what is Grafana does. It's a very widely used tool in reality because we just don't need numbers. We need visualization in the form of pie charts or the bar charts and all. Any questions from anyone till this part? And then like we have added two targets, right? So then we can also customize it further. We can also have a Jenkins server. Let's say you want to monitor those Jenkins or jobs. We can do that. We can add one more target and customize the Grafana dashboards so that it just not only shows the metrics. Metrics should be translated into something like either it's a warning or a critical and all. We shall pick up the Jenkins one and customizing the Grafana dashboards in the next class. Any more questions from anyone in the topics we completed?
For now, okay.
All right, then we'll pick up from here in the next class. Thank you all. Good day. Bye, everyone.
Thank you, ma'am. Have a good day.